Good morning, calculus class. This is Miss G. It is Wednesday, May 6th, and I have for you today a few of the problems, actually I have all the problems I assigned yesterday worked out for you. Also, I hope you had a great day yesterday. So here, let's go. I'm going to do the left sum approximation first. So I kind of streamlined it maybe a little better than I did in my presentation, I hope. All we have to do is find the area of rectangles. So that is base times height. And so first we can look at all our rectangles, 1, 2, 3, 4. And we can see what all our bases are. 2, 2 units, 2 units, and 2 units. So everyone has a base of 2 units. I did that all the way down. Now we need the height. So now we have to figure out which side of each rectangle we're using to dictate our height. So this is the left sum approximation, so we're going to use the left side. So in rectangle 1, I take the left side, go up to the curve, draw a line parallel to the x-axis within rectangle 1. And so I'm going to use the left side 1 to dictate my height. So if I'm doing a left sum, let me just show you the overview here. If I'm doing a left sum, I'm going to use 1 in the first rectangle, f of 1, then f of 3 in the second one, then f of 5 in the third one, then f of 7 in the fourth one. I will never use f of 9 if I'm doing a left sum. If I were doing a right sum, which we'll do next, I wouldn't use f of 1 for the height of the first rectangle. I would use f of 3. And then for the second one, f of 5, then f of 7, then f of 9. But I wouldn't use f of 1 if I were doing a right sum. But here, we're doing the left sum approximation. So for the height of rectangle 1, I need f of 1, which means I'm going to go to my function and plug 1 in, which I did right here. So the base is 2, the height is f of 1. Plug 1 into the function, 1 squared plus 1 gives me 2. So my area for the first rectangle is 2 times 2, or 4. I do the second one similarly. My base is 2, my height is f of 3. Plug 3 in the function, I get 10. So that area turns out 20. The next one, the base is 2, the height is f of 5. Plug 5 in the function, and I get 26. So 2 times 26, 52. And for the third one, the base is the fourth one, the base is 2, the height is f of 7. Plug 7 into our function, we get 7 squared plus 1, which is 50. So 2 times 50 is 100. That's the area of the fourth rectangle. We add them all up, 4 plus 20 plus 52 plus 100, all those 4, we get 176. We can see that it is an underestimation because we're missing all of this region, which is between the curve and the x-axis and the boundaries of 1 and 9. Okay, so there you go with the left sum. Now the right sum, same function, same graph, but now, and all the bases are the same, so all the bases are 2. The height, however, of the first rectangle, we're not going to use f of 1, we're going to use f of 3. So in drawing my picture, I go over to 3, go up to the curve, and draw a line segment parallel to the base of rectangle 1. And then for rectangle 2, I use the right side, I go up to the curve, hit the curve, and I draw a line parallel to the x-axis. Rectangle 3, go up to the curve, right side, go up to the curve, draw a line parallel to the x-axis, and come down. And rectangle 4, right side, go up to the curve, hit the curve, draw a line parallel to the x-axis within rectangle 4, and come down. All right, so there are my rectangles. So now I just need base times height. As I said, all my bases are still 2, 2, 2, and 2. I need my heights. I'm not starting with f of 1 for the height of the first one because I'm doing the right sum. So I do the right side. So I'm going to end up with f of 3 for the first one, f of 3. For the second one, f of 5. For the third one, f of 7. And for the fourth one, f of 9. And then I just compute those. F of 3 is 10. F of 5 is 26. F of 7 is 50. And f of 9 is 82. And then I work it out. 2 times 10 is 20, 2 times 26, 52, 2 times 50, 100, 2 times 82, 164. And I add them all up. 20, 52, plus 100, plus 164. Our approximation is 336. We can see that's an over approximation because we're getting all this extra region above the curve here. So this will be an over approximation. All right, the third one is the midpoint sum. Again, our bases are all the same, 2 units, 2, 2, 2, 2 for the bases. The heights are going to be dictated by our x values that are the midpoint of the base of each rectangle. So I found all my midpoints. Halfway between 1 and 3 is 2. Halfway between 3 and 5 is 4. And again, if you can't figure that out, you average. 5 plus 7 is 12 divided by 2 is 6. There's the midpoint. 7 plus 9 is 16 divided by 2 is 8. So they're all my midpoints, 2, 4, 6, and 8. What I have to do with those midpoints is plug them into the function to get the y value, which dictates the height of each of these rectangles. So I take 2, plug it into the function, I get 5. So for my first rectangle, base times height is 2 times 5, or 10. Second one, 2 times f of 4. F of 4, plugging into the function, is 17. 2 times 17 is 34. So the area of the second rectangle is 34. Third one is going to be 2 times f of 6. F of 6 is 37. That gives us 74. 2 times 37, 74 for the third one. And for the fourth one, is the midpoint is 8. So the height is going to be f of 8. Plug 8 into the function, I get 65. 2 times 65 is 130. Now I add them up. 10 plus 34 plus 74 plus 130, and we get 248. The midpoint is sometimes a little more difficult to tell whether it's an under approximation or over approximation by looking at the diagram, because we have some extra, but then we're missing some region. Some extra region, some missing region, some extra region, some missing region, etc. So we can see when we find the actual area by integrating how 248 compares to that. So here's the exact area. We integrate from 1 to 9 our function x squared plus 1. Find the antiderivative, 1/3 x cubed plus the antiderivative of 1, which is x. Plug in a 9 first, plug in a 1, subtract it, worked it all out, and got for the exact area of the region bounded by the curve of the x-axis and the vertical lines at x equals 1 and x equals 9 is 250 and 2/3, which as a decimal approximation is 250.667. The exact, without even rounding the decimals here, is 752 over 3. All right, so now I compared it with our 3 approximations. Our left sum in this case came out to be 176. It was an under approximation because it's less than the 250. 336 was an over approximation, and 248 was a little bit of an under approximation still. All right, so that's how those compare. Let's see what we've got now. Oh, we finished chapter 5. Yay! So now I have a few review exercises on page 370, numbers 1 to 13 odd. You might have to look at some old homeworks or go back and look at a video if you forget how to do those problems. All right? Anyway, hope you have a great day. Hope you understood the Riemann sums, and take care. Bye.